So the topic of today's video is graphing a quadratic equation in standard form. Our objective is I can graph a parabola from a quadratic equation written in standard form. So a quick review, a quadratic function in standard form is y equals ax squared plus bx plus c, and a cannot equal 0. So what do we already know about this formula? If a is greater than 0, our parabola will open up. If a is less than 0, our parabola will open down. If the absolute value of a is greater than 1, it's going to be narrower than y equals x squared. Y equals x squared is just our parent function, normal parabola with vertex at 0, 0. And if the absolute value is less than 1, our graph is going to be wider than y equals x squared. Now what's new is our vertex has an x-coordinate of x equals negative b over 2a, and to find the other point for our vertex we need to plug our x value into our equation, solve for y, just like we've been doing, and our axis of symmetry is also found at the vertical line x equals negative b over 2a. And lastly, our y-intercept is just equal to c. So from our standard form equation, our y-intercept is c, and it is always at the point with the x-coordinate 0, y-coordinate of c. So we'll start off with an example. So y equals x squared minus 2x minus 3. Start out trying to find our axis of symmetry. We have negative 2 over 2 times 1, our a is 1, so that is equal to positive 2, negative of a negative is positive, over 2, so that is equal to 1. To find our vertex, we need to plug 1 in for x. To find our y-coordinate, so we have y is equal to 1 squared minus 2 times 1 minus 3 is equal to 1 minus 2 minus 3, and that will come out to be negative 4. So our vertex is at 1, negative 4. Put that in our table. Go ahead and plot that point on our graph. We have our axis of symmetry at x equals 1, negative 4. And then our y-intercept is c. So we have that negative 3 here. So our y-intercept is at 0, negative 3. Put that point into our table. 0, negative 3. And then we can flip this across our axis of symmetry. Plot that point at 2, negative 3. Now we need one more point before we need 2 more points to plot our graph. So if we pick negative 1 for x, we get y equals negative 1 squared minus 2 times negative 1 minus 3 is equal to 1 plus 2. Negative times a negative is a positive, minus 3, and that is going to equal 0. We have negative 1, 0, plot that here, and again flipped it over our axis of symmetry, plot that point at 3, 0. So now we can draw our parabola. Okay, next example. Our a is a fraction. We haven't seen too many of those yet, so it'll be a little different. So we know it's going to open down right away. We have a negative a. Find our axis of symmetry. Take negative b, so our b is negative 1, so we're going to have positive 1 over 2 times negative 1 half. 2 times negative 1 half is negative 1. 1 divided by negative 1 is negative 1. Then if we want to find our vertex, plug negative 1 in for x, solve for y. So we get y equals negative 1 half times negative 1 squared minus negative 1 plus 1. It's going to equal negative 1 squared is 1, and then multiplied by negative 1 half gives us that negative 1 half, and then plus 1 plus 1 is going to give us negative 1 half plus 2, which equals 3 halves, or 1.5. Try that again. 1.5. So our vertex is at negative 1, 3 halves, or 1.5, whatever one you want to use. So we put that in our table, plot that point on a graph. Now our y-intercept is 1. It's our c, so our y-intercept can be found at 0, 1. And plot that point. And we can flip it over the x-axis, plot it at negative 2, 1. Then we need to find one more point we can plot, and then we can flip over the x-axis, or the axis of symmetry, sorry. So if I were to pick 2 for our x, get y equals negative 1 half times 2 squared minus 2 plus 1. 2 squared is 4 times our negative 1 half, give us negative 2 minus 2 plus 1. Negative 2 minus 2 is negative 4, plus 1 is negative 3. So 2, negative 3, plot that, 2, 1, 2, 3, and then we flip that over our axis of symmetry, and we get negative 4, negative 3. We go ahead and plot draw our parabola now. Okay, and our last example, y equals negative x squared plus x plus 12. So first off, again, find that axis of symmetry. Our b is 1, so we go negative 1 over 2 times negative 1 is negative 1 over negative 2, which is equal to 1 half. So find our vertex, plug 1 half in for x. The opposite of 1 half squared plus 1 half plus 12. That equals, for fractions, if we square the top and bottom, so we get 1/4, but it's negative, so we have negative 1/4 plus 1 half plus 12. Get common denominators. We get negative 1/4 plus 2/4 plus 12 would equal 48/4. That's going to come out to be 49 over 4, which is equal to 12.25. So our vertex is going to be located at 1/2 and 12.25. Go ahead and plot that. So 1, 2, 3, 4, 5, 6, 7, 8. Plot that right here, right above 12. Then our y-intercept is 12. So our y-intercept is going to be located at 0, 12. Put that point in, and then flip it over the x-axis, or axis of symmetry, and it'll be at 1, 12 as well. Plot our 2 points. We need one more point before we can draw our parabola. I'm going to choose -2, so we have the opposite of -2 squared plus -2 plus 12. So -2 squared is 4, but we have that other negative out here, so it is -4 minus 2 plus 12. -4 minus 2 is a -6 plus 12 equals +6. So -2, 1, 2, 3, 4, 5, 6. -2, 6. Flip that across our axis of symmetry. That's going to be at so that point is going to be at 3, 6. And again, draw our parabola. Okay, for review, quadratic equation in standard form, y equals ax squared plus bx plus c, and a cannot be 0. Our axis of symmetry is found at x equals a -b over 2a, and again that is our x-coordinate for our vertex. And to find our y-coordinate, we simply plug that in to our equation, solve for y, and you can find your y-intercept at point 0, c, right from our equation. Make sure to go online, do your reflection, get the bonus point, ask any questions you might have, and we'll see you tomorrow.